Good evening, everyone. Good evening here in Belgium, at least. Good morning, good afternoon, good night, wherever you are. We are here live at DevNation, and we have a really exciting talk for us tonight, or whatever time zone you're at. And with me, I have two really special guests. We have Benedict and Pavol. Hello, Benedict and Pavol. How are you?
Doing well, thanks.
Where are you from? Where are you joining us from?
I'm joining from Switzerland, from Neuchâtel.
Ah, nice. And what about you, Benedict?
Yeah, doing good so far. I'm joining from Germany, so almost in the
Excellent.
middle, close to
All
Cologne.
right. So we're not so far, relatively speaking. All right. So you have a talk about OpenTelemetry on Kubernetes. So with that, I think I'll hand over the word to you, and I'll share the slides. Who's going first?
I'm going first.
Okay. And do you have like intro of yourself in there, or do you want to introduce yourself first?
I have an intro in the slides.
All right. So
we can start that.
I'll share the slides, and then I'll sit in the background. So if anybody has questions, please put them in the chat, and we'll ask them when there's a good time.
All right. So hello, everybody, and welcome to this session on exploring the power of OpenTelemetry on Kubernetes. We will be kind of talking about how we can collect traces, metrics, and logs on Kubernetes by using OpenTelemetry operator. Before we jump into the topic, just quick intro for myself. I'm a principal software engineer at Red Hat and active contributor and maintainer of OpenTelemetry operator and Jaeger project as well. If you would like to reach out to me after the talk, you can do that on Twitter at Pavol LoffayModern. And when I'm not working, I'm usually spending my time in the Alps doing some freeride skiing and mountain biking. Benne, would you like to introduce yourself?
Sure. Yeah, my name is Benne, and I joined the distributed tracing team with Pavol a year ago. And since then, I'm mainly contributing also to the OpenTelemetry project. And yeah, that's almost it.
Yeah, thanks, Benne. So on today's agenda, there is a lot of things that we want to cover. And primarily, we will be talking about observability and OpenTelemetry, right? But we want to start maybe with explaining the history of open source observability, because we believe that if we understand the history, it will be easier for us to understand where the industry is going. After that, we will do an introduction to OpenTelemetry as a project in general and focus on how we can instrument the applications with the OpenTelemetry APIs, and then how we can collect this data that is coming from the instrumentation with the OpenTelemetry collector. Once we cover these basics, Benedict will focus on the Kubernetes environment by using the OpenTelemetry Kubernetes operator. And he will talk about the same concepts, right? He will talk about how the operator can be used to instrument the applications on Kubernetes and how it can deploy the OpenTelemetry collector. Once we cover this, we will go through 3 use cases. And so we will explain how you can use the OpenTelemetry stack to collect traces, metrics, and logs on Kubernetes. And last but not least, we will spend some time talking about what is coming next in the OpenTelemetry project. So let's move to the history. So on this slide, you can see a timeline, right? Starting in 2007 with Xtrace. And the timeline is divided into the bottom and upper parts. On the bottom, you see the open source projects, or you can call them platforms, that enable you to store and visualize telemetry data. Most of these projects kind of provide you with the capability to store and visualize distributed traces, but some of these projects as well are kind of end-to-end observability platforms that you can use for storing metrics and logs as well, namely Apache Skullwalking and Hypertrace and Cygnus project. However, I would like to focus on the upper part that shows the open source data collection projects. The kind of the first maybe open source data collection project that provided some APIs to collect distributed traces was the Zipkin project. And it defined stable data model that developers could use to export data from the applications. And the project as well hosted a couple of client libraries for different languages. But the problem was that those libraries, they were not kind of standardized, and they were using kind of different design principles how telemetry data should be created and exported. So it was kind of hard to use the Zipkin in kind of a polyglot environment. I actually did some experiment some years ago to try to use those libraries together in a polyglot environment. And we even found out that those libraries in some cases were not compatible with each other. So when some data were sent on the wire, some library was interpreting some data differently than the other library, and we didn't get consistent results to kind of collect a trace across processes. The next open source project that was trying to solve data collection was OpenTracing. And it kind of moved the industry forward because it defined the specification. That was a document that essentially tells you which data should be collected for specific events in a system. By event, I mean, let's say, HTTP call invocation or database call. And so let's say for HTTP call, the spec says that, for instance, URL should be collected, HTTP method, and so on. The project as well introduced API for instrumentation defined in many languages. And since there was an API, the authors could as well build a set of instrumentation libraries that could be reused in different runtimes. Then OpenCensus project came in a year later that had slightly different approach. It provided SDK, so not an API, but just directly SDK, and collector. So it was kind of big difference from OpenTracing, right? In OpenTracing, there was just an API, and developers had to choose which implementation to use. And in OpenCensus, there was a single kind of SDK, and then configurable collector that you would deploy in your environment. And in the collector, you could decide where the data should be sent, right? To which SaaS platform or open source system, like Prometheus or Jaeger. These two projects were kind of competing. And then finally, in 2019, they merged into OpenTelemetry. And OpenTelemetry really kind of provided all the goods from the OpenTracing and OpenCensus. So there is a specification, there is an API, there is an SDK, and as well the collector. But we will see that in a minute. However, the biggest innovation that I see in OpenTelemetry is the auto-instrumentation. Auto-instrumentation is essentially a binary or package that you can download, and it will automatically instrument your application and expose telemetry data. So when we kind of zoom out and we summarize what is happening in the industry, we see that we started with some instrumentation libraries that were using some bespoke APIs. Then we built some reusable instrumentation libraries that we were using across different frameworks. And finally, now we are in a state when we have in the open source high quality agents or auto instrumentations that we can just drop into our, let's say, Docker images and extract telemetry data almost for free from our applications. So where are we going? Maybe we are going into an era where we will not care about how the telemetry data is actually exported and created from the applications, because maybe the platforms, they will already, instrument applications fully automatically, as we will see how it can be done on Kubernetes. Or maybe the observability will shift left and developers still won't be instrumenting the applications, but they will start using telemetry data to solve other use cases, for instance, end-to-end tests. So this is for the brief history, and let's move to the OpenTelemetry project. So as you obviously know, OpenTelemetry is an open source project hosted in Cloud Native Computing Foundation. And the main goal is to provide vendor-neutral telemetry data collection. It's important to mention that OpenTelemetry is the second most active project in the CNCF after Kubernetes. So its scope is quite large, and it contains, several different components that can be used independently. So there is a specification, there is an API, an SDK, and a standardized data model called OpenTelemetry Protocol, or OTLP. So these four pieces are mainly used by, instrumentation developers or observability companies to create observability products. And then the last two pieces or components are the auto instrumentations or agents and collector, which are more developer focused. So as a user of OpenTelemetry, you would probably just download the auto instrumentation or collector. There is as well more pieces or more components in the project, but these are the kind of the essential ones. To facilitate OpenTelemetry deployment on Kubernetes, there is as well a Helm chart and Kubernetes operator. And as you can see on the slide, the OpenTelemetry works pretty much with every modern programming language. What I would like to stress is the OpenTelemetry is only for data collection. It's not a platform, it's not a storage or query API. So the main goal is only about how telemetry data is created and how it's then collected from the application and sent to a SaaS solution or some platform that provides storage and API capabilities, and query API capabilities. So let's take a look at the instrumentation, which is really the first kind of use case that we have to solve when we will be rolling out observability solution in our organization. So on this slide, we see kind of architecture diagram with three workloads. There is a front-end, driver, and customer applications. And each of these applications is instrumented with telemetry APIs. So each workload is using some logging API, each workload is using the meter API and tracer API to create spans. Once, we create logging statements or we, record some metrics, these telemetry signals are then sent or collected by the collector. Then in the collector are processed, maybe do some PII filtering, some relabeling, and once we are satisfied with the data, the collector sends them to a platform, which can be an open source solution like Prometheus Jaeger, or a vendor like Dynamics, Dynatrace, and so on. The most important here is the instrumentation, right? And what I would like to remember here is, or stress as well, is that if we want to get telemetry data, there has to be some code running in our applications that will create actually this telemetry data. It's not for free, right? And there are many approaches how we can instrument the application and put this telemetry API into our code. And now let's zoom into this box and talk about the approaches that we can take to create telemetry data. So there are three approaches. The first one is manual or explicit approach. The second is direct integration in runtimes. And the third one is auto-instrumentation or agent approach. So the manual approach is when we actually grab the API, let's say it's SLF4J for logging, and we use the logger to record some log statements, right? The same for tracing, right? We would grab the OpenTelemetry API, we would start and finish spans in the most important parts of our applications. You know, it can be in the business code, but it can be as well in the, most probably should be more in the like middlewares and frame and filters of the RPC frameworks that we are using. The approach offers a lot of control, a lot of flexibility, and if it's done right, the performance can be always quite high. However, to properly instrument applications, especially with tracing, is quite hard because we tend to forget about, for instance, instrumenting the error paths of the application. So let's say if there's an exception, we often forget to instrument those parts. And sometimes, we do the instrumentation, we change the application, and we forget to add the telemetry data, telemetry instrumentation. So it's easy to make mistakes when instrumenting application directly. This approach as well requires, our resources as developers because we have to do the work. And once the work is done, we still have to recompile and redeploy the application. The second approach is direct integration in runtimes. And some frameworks like Quarkus and Wildfly, they come with some telemetry integration that we can use out of the box. This is usually can be enabled by flipping some configuration option. Let's say in Quarkus it can be tracing enabled. We can set it to true, and then maybe recompile and redeploy the application. I would highly encourage you to use this direct integration in runtimes if there is any. However, the disadvantage is that the instrumentation for supported frameworks in these runtimes is usually limited. So maybe there is instrumentation for HTTP, but maybe there is missing instrumentation for gRPC. So you have to be kind of aware of what you are using, and so make sure that you are getting telemetry for all the important APIs that you are actually using in those runtimes. Last but not least, there is the auto-instrumentation or agent approach. This is the easiest to get started with because essentially you just download an agent from OpenTelemetry, you put it into your Docker image, and then configure the JVM to pick it up at the startup, and you will get telemetry data for all the APIs that the agent supports, which is usually quite a wide range of frameworks. So it's easy. It is the easiest to get started with the auto instrumentation. However, as the agent supports a lot of frameworks and will instrument all the APIs almost in the application, then it might consume a little bit more memory, and it might as well consume a bit more CPU cycles, right? So you just have to be careful about that. But I would highly encourage you to take a look at the auto instrumentation when you are starting with observability. Okay, let's take a look at how auto instrumentation is supported in the OpenTelemetry. So in OpenTelemetry, there is auto instrumentation available for many languages. There is one for Java, C#, Node.js, Python, PHP, Golang. Some of these are more experimental, especially the Golang auto instrumentation that is based on eBPF. And some of them are already used in production in many organizations, like the Java agent. Maybe we should explain at least how the Java agent works at a high level. So the agent is a jar that contains, the instrumentation classes, and it has to be enabled when the JVM is starting, when we, executing the Java command. What happens is that the Java will first load the Java agent into memory, and then it will start loading the application classes. So what will happen is that Java agent will see which classes are being loaded from the application, so it can inspect them and inject the instrumentation into the classes that needs to be kind of instrumented. It doesn't instrument your business code. It will just instrument the frameworks. So let's say the Quarkus classes, the Spring classes, the gRPC client classes. Then kind of the similar approach is used in C#, Node.js, and other languages. So, okay, we have figured out how to instrument the application, which means how telemetry data is essentially created. And now let's take a look how we can collect this data with OpenTelemetry collector. The collector itself, it's written in Golang. You can find documentation on the OpenTelemetry website. And there are two distributions of the collector. There is a core distribution that contains, a limited set of components or functionality, which is the OpenTelemetry receiver for receiving OpenTelemetry protocol, exporter for exporting data in the OpenTelemetry protocol, and some limited set of processors that process the data. I will talk about that on the next slide. The second distribution is a contrib distribution that is hosted in the OpenTelemetry collector contrib. And this one contains pretty much all the functionality for the collector that is hosted in the OpenTelemetry project. If you would like to see which components it includes, you can go to OpenTelemetry collector contrib repo and go to the receiver, processor, and exporter directories to see, which components are there. If you are not satisfied with the collector functionality, you can build your own collector with your own set of components. It's a very well supported use case in the OpenTelemetry project. Then these two collectors, the core and contrib, are distributed as binaries that you can download, or a container image, or a package for Linux systems. So what we see here is kind of the architecture of the collector. So we see the application reporting data to a collector, and a collector is essentially a data pipeline that consists of 3 steps or 3 kind of component types. The first component type is a receiver that usually opens a port and receives some data, or it can read a file from a file system, like we will see for collecting logs. Then the data goes to processor that processes the data. It can batch the data, do some PII filtering, relabeling, deduplication, maybe some data normalization. It can as well drop the data. And then once we are happy with the data, then the data goes to exporter, which exports the data to a system of our choice. On this slide, there is only a single pipeline, but a collector can be configured with multiple pipelines. So maybe some data from some receiver will go to different set of processors and to different set of exporters. It's as well possible to configure the pipeline to export data to multiple systems at the same time, or to send data to another OpenTelemetry collector that will do another processing in the processors. So this is for the kind of general introduction into OpenTelemetry and into the instrumentation and collector. And now Bene will take over and talk about the OpenTelemetry Kubernetes operator.
Awesome. Thanks, Pavol. Can we switch the slides to my screen? Perfect. Yeah, so we have seen how basically we can inject the auto instrumentation or create a collector. And now we want to have a more detailed look how this works on Kubernetes. So Kubernetes, you can imagine if you would go with the agent part and you need to add this to every deployment, this becomes quite tricky. And therefore, there is an operator which will help us and make life easy. And what does the operator do? It's basically offering us two custom resource definitions. One of them is the instrumentation, and the other one is the collector resource definition. We will have a more detailed look on it afterwards. And otherwise, if you would like to play around with it, install it, and use it, I would like to mention here that you can use the OLM, which is the Operator Lifecycle Manager. So you're probably familiar with it when you're on OpenShift. And then in the upstream community, you will also find Helm charts and the Kubernetes manifests for it. So let's start with the collector CRD. There are a few things in the collector CRD I would like to highlight here, and that's the deployment mode. So it makes it quite easy to expose your collector in different ways. So for example, and also use it in different ways. So if you're going for collecting logs, for example, you probably want to to deploy your collector as a daemon set. If you're offering it as a service for, let's say, some edge devices, you can go with a deployment. This deployment is then also directly able to auto-scale. And this is everything, also stuff that the operator will take care of. Also, for exposing your collector, then this is also quite easy. There is an ingress entry. You will find it in the documentation, and it's usable on OpenShift as well as on Kubernetes. And it will take care of forwarding basically everything that you want. And the last point here to mention is the image. So probably you're asking why the image. The image is important because maybe you want to have a different image with different capabilities than the core image, since the operator originally ships the core image, and there you don't have support for, I think, barrier identification and other things. So here we see a CRD. It's an example, and in the top left corner, you see there is a new kind, and this kind is the OpenTelemetry collector. And when you look under it to the receiver part, there we see basically what Pavol showed in the previous slides with the we distinguish between a receiver and an exporter and so on. And that's basically how it gets configured. It's the standard OpenTelemetry collector configuration. Here we see in the receiver section, it receives OTLP, gRPC something, so it traces logs and metrics on a specific port. And in the next section, we have an exporter configured. In our case, it's for demo purposes. It's just a logging exporter, but here you could configure exporters to forward your information to Splunk, to a security system or something else. And in the service section, we can then glue things together. So imagine we have some specific protocol which should have a different processor enabled and forwarding things to a legacy system, so you can build a pipeline for it. If you would like to have a different destination for your metrics compared to your traces, you can also build a pipeline for this. With the processors, you usually would then also specify directly in the configuration. You can see it here on the right side. As an example, we have a batch processor, which is then batching your measurements before continuing and sending them away, or the resource detection in OpenShift, which will enrich your data with quite useful information. So like from which node is your telemetry data coming and so on. And the last component, which is there, is basically those are extensions. So you will find a lot of different extensions, for example, for authentication, or just setting some headers for HTTP and gRPC requests, as we can see it here in this example. Okay, then we have the next CRD, which is then for the auto instrumentation. As we have seen previously, the auto instrumentation in Java, you need to add the agent. In different programming languages, it's also different. And when we roll it out, probably we don't want to care that much about it. And therefore, we have this instrumentation kind here. And you see it also there on the top left. So now on the OpenTelemetry API, we have a different kind. And the specification looks a bit different. So here we have the exporter and the exporting endpoint. What we are doing here is basically forwarding some information, probably trace information, to this destination. And to do so, for example, with a Java application, that's what we will see in a demo in the next slides. We go and just add this annotation you see on the right side on the pod level. And in case you have a pod with multiple containers, so like say there is a proxy that you don't want to instrument, you can also directly pass the app name there in the second annotation for the container names so that your proxy gets ignored. Okay, so we have three things then to speak about, which is tracing, logs, and metrics. And we will start with traces. So therefore, we prepared a demo which will illustrate an application which is not instrumented at all. It's a Java one. We will set this annotation, and by the help, you can see on the right top right corner of this instrumentation kind, it will be then auto-instrumented. And afterwards, these traces get sent in our test setup to a Jaeger instance, where we then can go forward and inspect them. So let me share my entire screen. Oh, does it work? Yeah, so now it works. Okay, so when we go to the setup, we go here, that's the page. It's the pet clinic, and we can click around, but we don't receive any information from here. If we go to our Jaeger page and refresh it, there is no service found. So when we have a more detailed look on the pod that is up and running, we see that we have basically one container. It's my app, and it's running a specific image. And yeah, there are no environment variables, so it's quite empty. So what we prepared here is this auto instrumentation. This will go and send information to the simples collector. And this is the Jaeger instance you have seen there a second ago. And when we go to the demo application and change this annotation from false to true, so you see also the deployment again, and apply this, it will take a second or two to start up. So probably until then we receive an error of 500. So there it's coming. And now we start clicking around. So we are searching for an owner, maybe clicking on someone. So we have here owners 1. And as soon as we refresh the Jaeger page, we see here now this new service which was added. That's the service name that we specified. Find the traces. And here we see a lot of different traces. Also, the entire history of the trace. But we can go to just a single span to see what happened here. So you see that we added the telemetry data, the SDK information about the JDK, what the SDK looks like, and then also some Kubernetes specific information by default and so on. So here you see, for example, it's coming from a specific pod, a specific node, and other useful stuff. Okay, that's how it works with traces. Let's jump back to the slides. Okay. So next we have metrics. And the question here is often, why should I care about metrics with OpenTelemetry? I mean, there is Prometheus. And yeah, it starts with OpenTelemetry basically gives you the opportunity to get rid of Prometheus. And why do you want to do it? Maybe because you have limited resources on an edge device. There it can become quite useful. Another thing is with having the same labels of the specification of OpenTelemetry on all your signals, it becomes easier to correlate between them. And This is especially nice for security systems, but also for analyzing things. And the last point is you get in flavor of all the OpenTelemetry features, which is with the collector sending it to multiple destinations, for example, to Splunk to analyze it from the developer side, and on the other hand, to some security system which tells you there is something wrong in your system. And the question is now, how does the operator help us with that? And here you see the CRD of the OpenTelemetry collector again. And what changed here is the receiving part. So basically, when we go to the configuration on the bottom, we see in the receiver section, there is now a Prometheus receiver, which is configured. So by default, the OpenTelemetry operator is able to divide the static scrape targets you configured and this divided between your replicas of your scraping instances. Therefore, we go up to the target allocator section and we see if you enable it, you can then also define different algorithms. Currently, consistent hashing and least weighted is supported, to balance your scraping experience. And then in case you have already some Prometheus CRs in place, you can also reuse them. So the service monitors and the pod monitors. So therefore, you need to enable the Prometheus CRs, go to the service monitor selector and just pass it there. And then this gets also spread across your replicas. So there are a few things we need to be aware of, and that's in Prometheus. I was speaking about the labels and that things get labeled the same way. In Prometheus currently, not all symbols are supported. So, and since OpenTelemetry labels contain dots, and it doesn't work, so there are some issues to it. It gets automatically normalized. So there is a normalization package in place, but it will just replace all invalid characters with underscores. So that's something you need to be aware of. Another useful receiver I would like to mention here is basically the host metrics receiver, which gives you some insights about the host, how it's doing, and it's directly coming in the OTLP format. So next, I think Pavol wants to continue with logs.
Maybe a quick question that we saw in the chat. So Sebastian was asking if the sidecar does it use Envoy or is it a different kind of stuff?
So the sidecar for tracing is an OpenTelemetry sidecar. So which means if I have an instrumented application, I would so I don't need any service mesh or I don't need Envoy. I can just pass it to the OpenTelemetry sidecar. And from there, it gets to my destination, which can be another collector, which can be a message stream like Kafka. That's basically how it works.
Okay, thank you.
Yeah, the OpenTelemetry operator deploys only OpenTelemetry collector, not other kind of sidecars. All right, so it's my slides, as I see correctly. And so, thanks, Bene, for the tracing and logging and metrics use cases. And I will continue with how we can collect logs on Kubernetes with OpenTelemetry operator. Before we dive into that, I would like to spend some time talking about the logging vision in OpenTelemetry. So because it's quite different than how OpenTelemetry treats tracing and metrics. So the tracing and metrics API in OTel were created kind of from scratch. It was a greenfield design. And it was because the project authors, they believed that there is still some room for kind of new metrics and new tracing APIs to be adopted by developers. With logging, the situation is different because there is already so many logging frameworks that are widely used by people, and usually people are happy with those frameworks and APIs. So the approach is different in a way that OpenTelemetry doesn't provide logging API for developers. It provides logging API, but it's meant to be used by the logging framework developers to create OpenTelemetry appenders. So this is one part of the logging in OpenTelemetry, and the second part is the protocol for exporting logs, which is the OpenTelemetry protocol. So that's for the vision and how to use it on Kubernetes. So there is file log receiver in the contrib distribution of the collector. The configuration is quite large and complicated, and you can find it on this link. I will share the slides after the talk. But essentially what it does, it will configure the receiver to read logs from the var logs directory on the Kubernetes node. And then it configures sets of operators, which is a concept of the file log receiver, to parse the logs and extract, let's say, timestamp, date, and some attributes, as we will see on the example. The receiver as well automatically adds the Kubernetes namespace name, pod name, UID, and container name to the log statements, or to the metadata associated with the log statements. So this is essentially, you would use the file log receiver when you want to directly read the logs from the node file system with the OpenTelemetry collector. If you are using already like Fluent bit, then there is Fluent forward receiver in the collector that can receive the data from the Fluent bit to the collector, and then you will get all the features in the collector to process this data and send it to another destination. So what we see here is the architecture. We have a Kubernetes cluster with 3 nodes. The collector is deployed as a daemon set because it needs to read the logs from all the nodes, and then it will talk to your platform, where you want to store the data. You can as well put some collector in between that will do some additional processing, but usually the collector on the node would talk to the storage directly. So this is the configuration of the CR, and there are 3 kind of important parts. The first one is, as I mentioned, the collector needs to be deployed as daemon set. The image needs to be the collector contrib, because the file log receiver is hosted in the contrib. And then it needs to mount the var log and var lib docker directories from the host. So what we see here is a console output from the collector. So in this case, the collector is configured with the file log receiver, and it's exporting data to the standard output. What we see here is a kind of a log statement that contains resource attributes. So the resource attributes are kind of set of attributes that apply to multiple log lines. In this case, we see the Kubernetes name, pod name, container name, and so on. Then there is a first log line that has a severity, body, which is a string. And then on the next slide, we see as well some attributes associated with this specific log line. The most important, or maybe not the most important, but kind of unique thing to OpenTelemetry is that the logs, they can contain the trace ID and spin ID. So if the process was instrumented with tracing, and the tracing instrumentation would put the trace ID and spin ID into the logs, we would get these 2 fields here as well that would enable us to correlate logs with traces directly. So this is it for the logging use case. And now I will be talking about what is coming next in OpenTelemetry. So in the operator, we'll probably see more contributions for auto instrumentations. There is already work going on for the web servers, so the Apache and Nginx. The OpenTelemetry project has as well a profiling vision. So maybe in the future there will be, profiles will be kind of officially supported signal that OpenTelemetry can kind of create and collect. And last but not least, there is Open Agent Management Protocol that has a separate specification hosted in the project and as well implementation in a couple of languages. So with that, I would like to finish and thank you very much for attention, and let's open it up for questions.
Thank you, Pavol and Benedict. I'm not seeing a lot of questions. We had some issues with the chat functionality in YouTube today. Apologies for that. If you are still not seeing the live chat, maybe try to refresh, or in your app, maybe reopen it or something, and then hopefully, if you have questions, you can still post them. We'll be here for a little bit longer. I noticed a question from Ravi, who said if the slides will be available later for viewing and downloading. I'm assuming yes. Will you post them on your Twitter maybe, or?
I will post them on Twitter and LinkedIn.
Okay, perfect. And I think, yeah, your Twitter handle is right there, so that's perfect. Let's see. So, and you're also presenting at FOSDEM, I noticed, next week.
Correct. Yes, we will be there with Ben as well.
Excellent. Yeah. So for those who don't know FOSDEM, it's a big open source conference in Brussels, Belgium. So it's basically in my backyard. So that's handy. I'll definitely see you guys there. I'll be doing a talk on Quarkus in the OpenJDK room, if anybody's interested in that. And let's see, we have another question here. What if any is the relation with OpenTelemetry and Datadog?
So,
go ahead, Bene. Sorry.
I'm not sure if I did the question right. So what's the relation between the Datadog agent and OpenTelemetry?
Yeah, between the relation with OpenTelemetry and Datadog, if any.
Probably you can answer it better, Pavol.
It depends what is actually the meaning of the question. So I think on my slides, let me go back to the slides. Because agent is like overloaded term, I would say. And if you talk about the auto instrumentation as an agent, actually the OpenTelemetry agents or auto instrumentations are based on Datadog technology. So they open source those agents and donated them to the OpenTelemetry a couple of years ago. But if you are talking about Datadog, like the host agent that you deploy as a collector, then those and OpenTelemetry collector, as you compare these two, those are totally different. And even right now, the OpenTelemetry auto instrumentation differs quite a lot from the Datadog auto instrumentation, as far as I know. Those two code bases kind of diverged quite a bit.
Okay, thank you. I hope, Gurul, that answers your question. And I noticed Tomas said they were mentioned together in 2019, which that shows on your slide too, so that checks out. Any other questions in the chat? I don't see any further questions. Let's see. So Gurul says, thanks. I got confused when I saw both being mentioned on that slide. So I guess that's that's where that comes from. And then we have a question that's, can OTel be used in apps running on VMware VMs for log analytics or even metrics/tracing?
I'm not familiar with VMware's technology, so I can't really answer.
Yeah, so I think it's Yeah, applications running on VMs for log analytics. So I guess it doesn't necessarily matter if it's on VMware, but maybe I'm wrong.
Yeah. Yeah, the collector and the auto instrumentation libraries that they can be deployed on any platform pretty much. It's not specific to Kubernetes or Linux or anything like that.
Right. Okay. That makes sense. Does that answer your question, Robbie? We'll see. If not, and please, if there are any more questions, post them. We have a few more kind of things that we can announce. So one of them is we started a DevNation Insiders program, and I can share the link. And so basically, this is a program where you have the chance to influence future products, to test drive new products and services for free. You can participate in the UX research and get access to insiders only events and stuff like that. So if you're interested in that, you can sign up using that link, and could be kind of interesting. Of course, be aware this is not something to directly run on production, but if you want to be part of the kind of testing and have some influence on the products, that's a great way to be involved. Pavol and Benedict, what if somebody wants to participate in the OpenTelemetry project? Is that something that they can do on GitHub and start contributing, or is there something special that they need to do?
Yeah, absolutely. I think every contribution is pretty much welcomed, and the project is hosted on GitHub under GitHub/open-telemetry. And yeah, feel free to create issues and open pull requests if that would be the best. And then we are on the CNCF Slack. There's a couple of rooms that you can join to talk to us. Specifically for the OpenTelemetry operator, there is as well, I think, called OpenTelemetry-operator channel room that you can join.
Okay, nice. Looks like we have another question. Let's see, from Tomasz. Did we already answer it? No. What are the limitations of OpenTelemetry collector, maybe compared to other collector delivered by paid vendors like Datadog or Dynatrace?
Yeah, it's a very broad question, I would say. I don't necessarily know what are the features of those paid solutions, so it's hard to say. But I would take a look at it from your kind of needs, that what you want to solve, and then try to find an alternative in OpenTelemetry.
Yeah, that makes sense. I mean, it's nice with OpenTelemetry. You have a fully open source project that you can influence and even contribute to, like we were just saying. But of course, it depends on everybody's use case, whether maybe there's a feature in the paid products that that's something that you need in your project. I see another question, or yes, it's a question. I saw log collector scans varlib Docker directory. What about other CRIs?
You can configure the directory to do whatever you want, and as well exclude use some wildcard to exclude files from that as well.
Yeah, right. So if you want to use, let's say a Podman or a Cryo or whatever, that shouldn't be a problem.
And there are also some different parsers for different log formats, but I'm not super familiar with it.
Okay. And can share also in the announcements. We have, for example, Benedict's Mastodon handle that you can follow. Are you also on Twitter, Benedict?
Yes, but not that active. So
okay. Yeah, we'll not make comments about the whole Twitter thing. But yes, you can find us, or a lot of us, on Mastodon these days too. It's an interesting one, huh? Let's see. Are there any other questions? If not, I'm going to ask one more question to Benedict and Pavol, which is, what's the weather like over there? Are you getting any snow, or is it just as gray as in Belgium?
So it's not too far from you in Belgium, I would expect, but we have already some snow, and it's here for 5 days now.
Oh, okay.
So it's...
Yeah, not much in the city, but if you go a little bit higher, there is quite some snow over here. Yeah,
That's
but I'm looking forward for Belgium as well for the next week. So
yes,
yeah,
you will be here, won't you? Yes. And actually, I'll be in Switzerland in not too long to go skiing, or snowboarding. So I hope there will be snow. All right.
Yeah, it's a bit less this year, but yeah, it's still okay.
Yeah, can be. Yeah, last year I was very lucky. In December, I went to the French Alps, and there was a lot of snow, so I was very lucky. Okay, well, I don't see any further questions, so I think we can wrap it up. Thanks everyone for joining. Hopefully we'll see you soon at the next DevNation talk. You'll also find us at Devox UK. We're doing a DevNation live day, and so you'll see some interesting speakers, and myself as well. And if there are no more questions, which I don't see, then I wish you all a nice evening, nice rest of the day, nice talk, and see you next time.